All right, so moving on to example 3, it says simplify. And what we have going on here is we have a real number, negative 2.5, being multiplied by a complex number, 8 minus 9i. The complex number, just based on its own structure, a real number followed by an imaginary number, is going to be a binomial structure typically. And when we look at a binomial being multiplied by a single object, we're looking at the distributive property as how we do it. So if I do negative 2.5 times 8,
God bless you.
and then it's going to be plus negative 2.5 times negative 9i. Okay. So I take the outside piece, negative 2.5 times the first piece, the outside piece, negative 2.5 times 9i, the second piece, negative 9i, the second piece. Now, looking at this, the sign rules for this work like normal. I'm multiplying a negative number, 2.5, times a positive number, 8. I'm going to get a negative answer. 2.5 times 8 is equal to 20. And that is a real number. Okay. I'm multiplying a negative number, 2.5, times a negative imaginary number, 9i, negative 9i. When I multiply two negatives, I get a positive, so plus a positive is plus. 9 times 2.5 is 22.5, and then I. So it's just like multiplying x's or y's or z's. The numbers multiply to make a new number. The letter just comes along for the ride. So real times real made a real. Real times imaginary made imaginary. Real, imaginary order. That is the final answer to that simplification. Just basic distributive property going on. Nothing weird happening in that one. Okay. So let's move on to the second one and let's see what weird looks like.
Well, you don't finish that? That's just...
That's as far as you can go. Subtraction or addition with letters involved require that both things contain the same letter to add them. This has an I, this doesn't have an I, so addition, subtraction is not legal. We're allowed to multiply them as much as we want to, but we cannot add and subtract if they don't have the same letter sequence. Right. I is not a true variable, but it's acting like a variable it acts, so you can just pretend like it's a variable for the sake of the rules. The second one, we have 1/2 plus 2i times 1/2 minus 2i. We have a binomial structure times a binomial structure. And the way we multiply binomials in algebra, the easiest way is FOIL. Any type of distributive property would work, but let's just go with FOIL because that's pretty straightforward. Use some different colors here to identify what steps I'm using. So if I do the first object times the first object, what's 1/2 times 1/2? 1/4.
Oops.
Then if I do the outside times the outside, what's 1/2 times negative 2i? What's 1/2 times 2?
Negative 1/4 I.
1/2 times 2 is 1, right?
Oh.
So 1i and the opposite sign is negative, so negative 1i is what we get out of that product. 1/2 times 2 is 1. Different signs make it negative 1. 1i makes it negative 1i. Then I'm going to multiply inside times inside. That'd be these two. What's 2 times 1/2? 2 times 1/2. 1. They're both positive, so positive 1. And then I, right? Again, an I times a real number, right? Imaginary times real. 1/2 times 2 is 1 times I makes 1i. And two positives make a positive. Then I'm going to do last times last. I've got positive 2i times negative 2i. What's 2 times negative 2? Negative 4. And then I times I makes I squared. So, out of the 4 terms we create, we have a real number 1/4. We have an imaginary number negative 1i. We have a second imaginary number positive 1i. Then we have an imaginary number squared. And that's where we have to invent some new stuff. And not even invent, but we're just going to do a little math with I. Okay, so let me just do the math real quick with you, and we'll see that it's not that bad. Shrink this up a little bit, get out of the way. I'm going to do some work here. The end results are going to come over here. The end results are what you want to have on your paper. Okay. So if I is equal to the square root of negative 1, if I'm looking at I squared, that just means the square root of negative 1 times the square root of negative 1, right? Now, what we should know about square roots is when you multiply a square root times itself, you get the radicand as the answer anytime you multiply, right? So for example, if I have the square root of 6 times the square root of 6, I get 6. If I get the square root of 9 times the square root of 9, that equals 9. If I did the square root of dog times the square root of dog,
Cat.
I get dog. It doesn't matter what's underneath the radicals. When you multiply a radical by itself, you get what's underneath the radical as the outcome, right? So when we're doing the square root of -1 times the square root of -1, it's going to equal -1. Again, we simply invented an object that multiplies by itself to create a negative. It's not possible in the real world. That's why it's an imaginary number. Okay. So what I want you to see here is I to the first is going to be called I. I to the second is going to equal -1. If I continue on with this line of reasoning, I to the third power is just I squared times I to the first, right? Going back to Algebra 1, our power rules. A second power multiplied by a first power, you add the powers, you get I to the third power. What's I squared equal? -1, and -1 times I makes -1i, right? So I to the third power is equal to -I. If we look at I to the fourth power, that's just I squared times I squared. I squared is -1, and I squared is -1. What's -1 times -1? 1. So I to the fourth equals +1. If we look at I to the fifth power, that's just I to the fourth power times I, right? I to the first. What's I to the fourth power equal? 1. So we get 1 times I, which equals I, right? So it repeats itself. So this is the patterns of I right here. This is what you need to know. If you have I to any power, first, second, third, fourth, whatever, you can transform it back to either I to the first power positive, negative, or positive or -1. So coming over here, when I look at my -4i squared, this guy, what does I squared equal? -1. So I'm going to change that into -4 times -1, because that's what I squared equals. And -4 times -1 makes +4. All right? The imaginary piece went away because I squared is a real number. I to the fourth is a real number. I to any even power is a real number. All right? Notice also right here in the middle, these two guys. What's -1i plus 1i? 0i, which is just 0, right? 0 times anything is 0, including imaginary numbers. So that's just gone. So all we're left with then is 1/4 plus 4. Lawrence, what's 4 equal as a fraction? This is 4 over 1. How to make it into a common denominator? 1/4 plus 4, I want a common denominator. What do I multiply by?
4.
So we have 1/4, which is that fraction, plus 16/4, which is this fraction with the right denominator, which makes 17/4.
I'm on top of it today, huh?
So notice that if we multiply two complex numbers together, we have the capacity to create a real number answer. So it's possible to multiply imaginary complex numbers and get real answers. It's also possible to multiply complex numbers and get a complex answer. If you do end up with a real number and imaginary, go real first, imaginary second. But again, that's how you do it. Binomial multiplication, distributive property. If any I to a power shows up in your work, just transform it into one of these 4 possibilities. I to the fifth power is the same as I to the first, 6th, 7th, 8th, 9th, 10th, 11th, 12th. And the easy way to remember this little pattern here is real simple. I won. Imagine you just won a game, you're excited. I won. Put the negatives in the middle. I won. Negatives go in the middle. Real simple to remember, always works.
Why is it when you win a negative? It should be a positive.
The number 1 sounds like the word one.
Yeah, I
It's
know.
a mnemonic device, so you can memorize it.
I know, but like,
Alright.
it should be positive.